Hi, I'm Georgina Wood, Field Technical Manager for Syngenta. Today we're just going to have a little look through some of the information we've produced, particularly this year, about maximising pre-emergence applications as we head into the 2021 autumn season. So let's get started. Many of you watching will be familiar with some of the work that we've done, particularly at our Barton Blackgrass Innovation Centre, looking at integrated grass weed control and how an integrated approach can deliver much better results than focusing on just one strategy alone. So there we've looked at all sorts of things, including biological disruption, so trying to work around the weed's natural biology and disrupting that to get on top of it. We've looked at competitive cropping and also different chemical options. Alongside that, we've been doing lots of application work. And every year we've taken people around those trials and had to look at the different nozzle technologies. We've looked at forward speeds and water volumes as well. And you can see in the chart that's just appearing on the screen now, we think that application and fine tuning can be 10% of the control that you're getting. So often it's quoted the differences between products as a certain percentage, one adding over another. But actually getting application right can contribute 10% to that control that you can achieve. Alongside that, we've got timing and weather and mechanical setup, which of course are all parts of application as well. So we're trying to fine tune our application to get that sweet spot where we're going to get the maximum out of the products that we put in the tank. And if we have a look at the Venn diagram here, you can see that there's a crossover where you can improve efficacy, you can increase work rate and reduce drift. And we're looking to achieve this point in the middle here. There's some things that we can do to reduce drift, such as slowing down the forward speed. But if we do that to the extreme, we'd be moving over here and we would not be achieving good work rate. So it's all about finding that balance between efficacy, work rate, and reducing drift so that we're not having unnecessary environmental impact. And again, many of you will be familiar with the low slow covered mantra that we've been talking about for several years now. And that reflects the work that we've done, looking at keeping boom height at 50 centimeters for optimum application in terms of pattern that we're getting from the nozzles, but also reducing that drift as much as possible. Forward speed, limiting that to 12 kilometers an hour. Choosing 90% drift reducing nozzles where possible, and also using 200 litres a hectare water volume, as we've seen that that's delivered really consistent results in terms of efficacy from PM applications. And that consistency is something that we've seen, and you may have seen this chart before, and it shows it quite nicely. This is data from 400 trials from 2016 through to 2020, using different water volumes. And you can see in the blue bar, this is where we've used 50 litres a hectare. And in terms of the percent control that we've achieved, it's very, very variable. So from the top to the bottom of the chart is the variability in the control that we've achieved with 50 litres a hectare. And the lines are giving us the averages. So with this box and whisker diagram, to achieve consistency, what you're trying to do is have the box on that box and whisker diagram as small as possible, and that indicates that the majority of your results fall within a small area. So as we increase the water volume to 100 litres a hectare, you can see that we're achieving better control overall because the whiskers are getting smaller and towards the top of the chart. And also that box is reducing in size too, so the variability is decreasing. Again, if we move to 200 litres in the red, we're getting a really tight box and whisker chart there, and that's showing that we're achieving better efficacy more consistently. If we then look at where we've used 400 litres a hectare, you can see that there's not really any benefit over 200 litres. So 200 litres does seem to be that sweet spot where we're achieving really good efficacy, but also achieving that consistently as well. And our trials this year have reflected that too. We've looked at several different product comparisons with 100 litres and 200 litres a hectare water volumes. So this was done at the Barton site this year. We used 4 litres of Defy, 0.6 litres a hectare of Liberator, and 4 litres of Crystal in the different treatments. So if we start off by looking at the left-hand side of the chart, we're looking at percent control of blackgrass. And the dark blue lines are showing us the results from 100 litres a hectare, and the lighter blue are the 200 litres a hectare. And if we look at Liberator on its own, you can see that there is a small increase by using 200 litres a hectare. Where we add Defy to that mix, we're increasing the control again, and every time we're taking a stepwise move towards the 100% control that we need to achieve. We've then looked at Crystal, which again, where we're adding Defy into the mix, we're achieving an increase in control, but also water volume having a reasonable impact here too. So increasing from 100 litres to 200 litres with Crystal Solo. And when we've added Defy, we're also moving from 100 litres to 200 litres a hectare water volume, increasing in the control that we've achieved. So it doesn't appear to be a product specific response with the water volume. It does seem fairly consistent that if you increase the water volume, you do increase the control that you're able to achieve. And alongside that this year, we did some work to kind of visualize the spray coverage and distribution. So this work was done using a blue dye product and then looking at that through a drone where we can look at the different colors that we're picking up on the soil surface. So we can see where we've used different nozzles and different water volumes, how much of that product, which is represented by the blue dye, have we actually deposited on the soil surface. So if I reveal the plots here, you can see that there's differences in the amount of red and green colouring within those plots. So the green is picking up the blue dye. So the higher the proportion of green within those boxes, the more product we've distributed on the soil of that plot. And then to reveal what we've actually done here, you can see that we've got the different nozzle options, but also you can see that there's water volumes in there as well. So again, the dark blue boxes are showing where we had 100 litres a hectare, and the lighter blue boxes are showing 200 litres a hectare. Now from this, you can't really pull out any particularly big differences between the different nozzles themselves. But what you can see is that fairly consistently, where we've got 100 litres a hectare, we do have more of the red and orange colouring within the plots than where we've used 200 litres a hectare. So we are getting better spray coverage and distribution by using those 200 litre hectare water volumes. And why are water volumes so crucial at that pre-em timing? Well, if you think about what you're actually trying to achieve with your pre-em sprays, you're actually spraying a relatively small amount of spray solution over quite a big area. So it is actually a job that needs a certain level of precision. When we're looking at 100 litres a hectare water volume, that's just 10 millilitres of spray solution per square metre of soil area. And that's just 2 teaspoons of liquid over a metre squared. Now, you could go and map out a metre squared and just pour 10 mils of liquid onto that area and see that actually that's a really quite a small volume to evenly spread over that area. So we're expecting a lot of our spray technology. If we increase to 200 litres a hectare, we're doubling the amount of liquid that we're spreading over that area. So we have a much better chance of getting that spread over the whole area and getting that distribution a lot better. So this was just to highlight that actually that pre-em spray is a precision job and we need to think about the coverage and the distribution of that coverage that we're achieving with those applications. Now, if we move on to have a little think about drift, and that's something that we as an industry need to be really focused on and make sure that from an environmental point of view, we are limiting that as much as possible. It's often said that drift never leaves the field, you know, it just lands in the same field as where it's been created, so it's not a problem. I think the picture on the left-hand side here highlights quite nicely that that's not true. And you can see that where a spring crop was going to be drilled in the field on the left-hand side, it's been sprayed off with glyphosate, and you can see where that was done in quite windy conditions, and with every gust of wind, some of the spray has been taken through the hedge and into the neighbouring winter cereal crop. So the impact that that's had on the hedge is not something we really want to have to think about. But also in terms of public perception, this is right next to a main road, and of course is not something that we want to be doing. So we really do need to focus on reducing drift where possible. And we've done some work with NRoSO spray application unit. This was done many years ago, and it's looking at different types of nozzles and their relative drift reducing capacity, and how that helps them to respond in suboptimal conditions. So in the autumn, we often have weather that is not ideal for spraying. So can drift reducing technology help us to mitigate against that when some of those conditions are slightly more borderline? And if we're looking at the chart, what we've got on the y-axis here is the relative drift at 5 meters. So that's our measurement of the amount of drift that is happening. Along the x-axis, we've got the wind speed. So we're going from ideal spray conditions at 1 to 2 meters a second into compromised spray conditions in the yellowy kind of background color, and then into higher wind speeds where spraying isn't advisable in the red. And if we just have a little look at the different types of nozzles that we've got here, the flat fan, standard flat fan nozzle is the green here. And you can see that as soon as wind speeds are higher and we're getting into those compromised spray conditions, we are getting much more drift from those flat fan type nozzles with smaller droplets. If we then look at a 75% drift reducing nozzle, something like the Amistar nozzle, that's the dark blue nozzle, dark blue line that we have here. And you can see there's a really big decrease in the amount of drift at those higher wind speeds where we're using 75% drift reducing technology. If we take that a step further, where we've used the TJet TTI nozzle, which is the dark orange at the bottom here, you can see that there really is a huge reduction in the amount of drift from those 90% drift reducing nozzles, which is only going to be a good thing in terms of looking after the environment. But does that actually help us when we're thinking about getting the most out of our pre-emergence sprays? Well, yes, it does. Because having droplets which are actually going to land in the field is, you know, we're putting the product where we actually want it to work. So that is number one reason why drift reducing technology can be a benefit for our pre-em sprays. And even within the field, which you can see the fields kind of represented as these squares here, in conditions that can lead to drift, you would see potentially uneven applications. So you'll have areas of the field which are underdosed and areas which are perhaps overdosed as well. If we mitigate that by using drift reducing technology with bigger droplets which actually land in the field where we want to put them, our distribution of spray is much better. So we don't have these underdosing and overdosing areas. With larger droplets, we perhaps don't have the same coverage in terms of absolute coverage of the soil surface, but where every droplet lands, which I've represented with the grey squares, alongside that you then have kind of a gradient of dispersal of the active ingredient. So all of this would be covered in a light grey. So that distribution of active ingredient across the soil surface is very good in the square box on the right-hand side. And what we don't want is to have areas which are underdosed or completely untreated, where drift is moving product around in the field, because that's where we will see weeds emerge. And we've done some work this year looking at the Defy 3D nozzle versus our new development, the 3D 90 nozzle. And we have seen an increase in control that we've achieved with that 3D 90 nozzle. So the 90% drift reducing technology is actually helping us to deliver a better result in terms of weed control, as well as helping us to protect the environment. And so there's lots of 90% drift reducing nozzles out there. Choosing one to fit the right situation is something that we need to have a look at. And like I say, Syngenta's done lots of work looking at the different benefits of these different nozzles over the years, especially with the upcoming introduction of the 3D 90 nozzle. So we've looked at 3 different types of drift reducing nozzles in some of the trials this year. And the 3D 90 and the IDTA nozzles that you can see on the screen here, so these 2 bars, have a greater angle than the TTI nozzle. The TTI nozzle is doing a pretty good job, but actually I think where we've got that greater angle, we are seeing just a very slight increase in control. And that may be where we had a slightly cloddy seed bed. That angle is helping us to get a more even distribution of active around that 3D surface rather than a pan flat soil surface, which unfortunately we couldn't achieve at Barton this year because we were late drilling into fairly wet conditions, so the seed bed was not ideal. So nozzle angle is something to also consider as part of choosing your 90% drift reducing nozzles. And again, just having a look at some of the work that we've done to develop the 3D 90 nozzle. We've been looking at comparing 3D 90 nozzle against the flat fan and doing that with different product options. So here we're looking at stacking improved application with more active ingredients as well. So on the left-hand side, if we start, we've got the flat fan with Liberator, so that's 0.6 of Liberator, where we have used the 3D 90 nozzle. We have improved control with that solo product that we have in the tank. We then move across to the next bar. You can see that we've added Defy at a rate of 4 litres into the mix here. And we're increasing control again by adding that in versus the Liberator. But if we use the 3D 90 nozzle, we're again edging upwards in terms of the level of control that we're seeing. And again, we've done that with Crystal. And we can see that if we stack active ingredients and better application, every time we do that, we're edging further and further towards that 100% control that we're looking to achieve. And so far, we've focused quite a lot on blackgrass in the examples that I've given, but ryegrass is an important target as well. And focusing on ryegrass with pre-emergence applications is something that I know is becoming much more of a target for lots of people around the country. So just to show you some data on ryegrass from our Ryegrass Innovation Centre at Doncaster, this is from last year actually. Again, we can see that that 200 litre a hectare water volume is also relevant in a ryegrass situation, where we have the 3D nozzle at 100 litres a hectare versus the 3D nozzle at 200 litres a hectare. You can see there's a really significant improvement in the level of control. And that rings true for each of the different nozzles that we used in this trial. So the 3D 90 nozzle, again, really significant improvement in control, and with the TTI as well. And in terms of other ways that we're trying to help you to spray in the best possible conditions and choose the right nozzle to be able to do that, Syngenta have developed the Spray Assist app, which helps to give alerts on whether or not spraying is advisable based on your own postcode and weather forecast and conditions there. So it will give you a nozzle recommendation to account for what type of spraying you're doing. Is it pre or post M? And also the weather conditions at the time. So it's a really useful tool to be able to see whether or not you should be leaving the farmyard and heading out to that field to spray it. And if so, how should you be setting up the sprayer in order to get the best results? So I'd really encourage you to download that and use it to help get the best out of your pre-emergence applications this season. And just to summarise, we kind of saw all of this at the beginning, but remembering that low, slow, covered mantra is really important to help us get the best out of the products that we're putting into the tank, because what we're doing when we are doing our applications is actually around 50% of the control that we're getting, we can influence by getting these things right. So just to summarise, point number one is to ensure that sprayer setup is optimized and correct. Keep that boom height at 50 centimeters. Don't spray at more than 12 kilometers an hour. Use the 90% drift reducing nozzle, and it will give you consistent results without compromise. We've consistently seen that 200 litres a hectare is better than 100 litres a hectare, and that's across many seasons and multiple different product comparisons as well. We've seen that angled nozzles can help to give small percentage increases, especially where seedbed conditions are not ideal. And also download that Spray Assist app for up-to-date, accurate, local advice for you on your farm. So thank you very much for watching. I hope you've enjoyed it. So now I'm joined by Matt Kettlewell and Scott Coburn, who we're just gonna have a little talk through a bit of a Q&A and address some of the relevant questions that you guys might have out in the field. So over to you, Matt.
Thanks, Georgie. Yeah, so Scott, I suppose main questions that I come across quite often is obviously nozzle choice, and particularly across sort of all scenarios, whether it be pre-em, peri-em, post-em. So obviously we've got different sort of targets at those points, as well as just sort of crop safety issues. But thinking in terms of ideal conditions and whether it's suboptimal conditions, and particularly as we try and encourage everyone to use pre-em over anything else, because you get best efficacy and safety out of the products. What are the kind of nozzle recommendations this year for those products, those pre-em products?
Yeah, I mean, good question, Matt, really. And I suppose what it should start off by saying really is that, and we've probably mentioned this quite a lot in the past, that the decision in trying to get best application is a juggling act. You know, we're balancing sort of essentially three elements: application and efficacy of the product. We're balancing looking after the environment, and then the third sort of element is we're trying to match work rate around there, and that will, you know, those three factors will vary from grower to grower. You know, they'll have they'll put some in a higher priority than others. But if we're looking at specifically nozzle choice for the pre-em job and what, you know, makes the decision, well, you know, we are very much thinking about the weather conditions on the day we're doing the job and the seedbed conditions to try and achieve the best possible outcome. And the spray operator should be prepared to be flexible in that decision-making process. They shouldn't go out with a mindset in the morning that says, oh, I'm going to go at 100 litres and I'm going to stick with that the whole day, because the weather conditions and possibly the seedbed conditions are going to vary through the day. So they should be prepared to be flexible, and hopefully on their sprayers they have enough nozzles to allow them to be flexible and to change as they go on during the day. So specifically, you know, if I was thinking of sort of absolutely perfect conditions for applying a pre-em, you know, where we're maybe looking at our worst blackgrass fields in a decent seed bed, and in good weather conditions, then very much I feel that our old 3D nozzle would suit that situation very well. I would still suggest, and a lot of people will still use it at 100 litres a hectare, I would still suggest that actually, if you go up to 200 litres a hectare, you will get better results with that. And then, you know, as seedbed conditions change and as weather conditions change to perhaps slightly windier, although we're not obviously not advocating people go out spraying when they're going against a code of practice in terms of wind speed, then that's when you would make the decision to switch to a coarser spray, something like, you know, a 90% drift reduction nozzle, and you know, primarily we would be looking at the TJet TTI, and going forward we'll be looking at the 3D90 as being the main nozzle of choice from that. And when I say that, you know, if we were in good conditions looking at a 3D nozzle at higher water volumes, if you then switch later on to a TTI nozzle and you're at those same water volumes, say 200 litres a hectare, then actually the switching over from the 3D to the TTI is a very simple process. You don't have to change your recommendation. You know, you're on 200 litres the whole way, and it's just the case of going around and flicking over the set of nozzles, and you're back in business. You don't have to think about, do I need to put more water in the tank or anything like that. You know, it's a very straightforward decision to go from a 3D 05 nozzle at 200 litres to a TTI 05 at 200 litres. You know, you just change the nozzle and nothing changes. So it's quite a simple decision-making process. And the other thing we said about seedbed conditions, you know, the whole premise when the 3D nozzle was designed to be this sort of give three-dimensional control, was thinking about clods and the like. And if you were running those nozzles forward and backwards, you're going to get extremely good coverage around clods with that nozzle choice.
So ideally, if I've got ideal conditions in terms of weather, like for example wind, and obviously I'm controlling the sprayer at the right speed, but I've got a cloddy seedbed, which obviously is a bit more common now, with particularly going down to min till, zero till.
Yeah,
that 3D is still a justifiable.
I think that 3D very much is justifiable. In the future, you know, our 3D90, which is builds on that 3D technology, will absolutely fit that bill for, you know, ideal conditions and when things become inclement. But until that arrives, then the 3D is still a superb choice in perfect conditions with a cloddy seedbed.
So actually the 3D90 will sort of bring together both the TJet advantages and the 3D
absolutely
define nozzle advantages.
And it will bring, you know, a nozzle that, you know, with your hand on heart, that you are achieving the LERAP ratings at a correct operating pressure. Mm-hmm. You know, the 3D nozzle is very good. It's, you know, 3-star rated, but not at operating pressures that are suitable for carrying out the job, if you like. But the 3D90 and the TJet fill both of those criteria, really.
Okay, we're not putting too much on the spot, but things like peri-em and post-em at those ideal conditions, does that give more value to a 3D nozzle? Because obviously we're trying to potentially hit an actual target other than soil, then, aren't we?
Yeah, absolutely. Again, that is quite a challenging timing, and probably the 3D nozzle, because it, even at 200 litres, is probably still fine. It's producing a finer droplet spectrum than the TTI. It is going to do a better job on those very small emerging blackgrass plants. So I would, you know, look at it in that scenario as well.
And water volumes, we can potentially drop down in those periems?
Yeah, potentially. I mean, water volume, you could potentially. I think I'd still be happier at 200 litres, Matt. But potentially you could pull things back down. It's always a compromise. The water volume bit. You know, you'll hear people saying, you know, I must go at 100 litres because I've got such a big area to get round. And if I don't do that, then I might have some fields that we don't get sprayed. Well, what I would say is, you know, increasing to 200 litres a hectare, you don't actually compromise as much in the way of output as you would expect. You're not half an output by going to 200 litres. And as a spray operator, you know, it gives you the opportunity to look at other areas that you can save time with, you know, save time in the filling process, and you know, maybe get somebody bringing water to you rather than having to run back to the farm the whole time. So there's things that you could look at to try and increase your output again.
I often like to add there as well, sometimes you're in scenarios where you might have only drilled 40 or 50 hectares that need spraying. So, you know, don't carry on with that mindset thinking you've got 1,000 acres to do. You can actually think, I've got a limited amount to do today. So actually, this is a great time to up my water volume because it'll fit in within the day's workload, don't it? So,
absolutely, you're absolutely right. You're not going to go out and spray your whole hectareage in 1 day or 2 days. It's going to be piecemeal through your drilling campaign. So far better that you try and do absolutely the best job that you can every time you take the sprayer out. Would be my opinion. You know, we're putting complex, expensive tank mixes together, and we absolutely want to make sure that growers get the best out of those tank mixes.
That's also something to remember when thinking about trying to have a suite of nozzles to choose from. If you think about the value of the product you're putting through them, just purchasing another set of nozzles to add to your armory is actually a small amount to increase on, isn't it?
It is. It's always a sort of thorny issue. You know, not, you know, having enough nozzles, and but, you know, perhaps, you know, yeah, we're talking maybe fractions of percent of your overall spray bill in terms of that nozzle choice. And we know that, you know, nozzle choice can potentially bring us another 5% plus in terms of control. You know, so the right nozzle can bring us 5% control over the wrong nozzle, and certainly over a set of worn nozzles. You know, it's money well spent, in my opinion.
Well, thanks, Scott. That's cleared that up for me. I think.
I guess there's one thing still that we maybe didn't cover there, and that's what if you are including a contact acting herbicide in your peri-em. I think that our advice in the past has been that in those situations, then 100 litres a hectare can actually be better because you're getting higher concentration of active per droplet, where you've got that contact active in the tank. So is that still what you'd recommend in those situations?
Yeah, I think you're right, Georgie. If, you know, you have to evaluate that whole situation again. You know, if you've got those contact products in there, and yes, lower water volumes, you will increase the concentration per drop. So, you know, I think that would be a sensible decision, definitely.
And then I suppose the other thing is, we've talked a bit about ideal conditions, and wind conditions in the autumn are, you know, often not ideal for the whole duration of a spraying activity, in terms of there being gusts, and obviously the later we get into that drilling campaign, the less likely we are to have those ideal wind speeds for using the 3D nozzle that you were talking about there. In terms of efficacy, I think what I've seen is that there isn't a downside to using a 90% drift reducing nozzle in terms of efficacy if I'm going at 200 litres a hectare. So would that be the right approach to kind of mitigate against that risk?
Yeah, I think it would. Yeah, you know, we've seen, and the application team are very convinced that we're not seeing a drop off in performance by going to a 90% drift reduction nozzle at 200 litres, they're performing extremely well. So yeah, I think that's absolutely right. You know, we, as I said at the start, we can't advocate that people go and spray in windy conditions, but we all know that, you know, a gust will just sort of come out of nowhere, and you wouldn't necessarily need to change your whole practice for that. But if it just gives you a bit of a comfort zone by using that type of nozzle, then that would be the right thing to do, I think, definitely.
I think personally that would be my choice, just to know that I were erring on the side of caution, particularly at that time of year.
It's risk management, Georgie, isn't it? You know, you're mitigating the risk by using those nozzles. You know, we know we've produced enough data to show that at 200 litres, 90% drift reduction nozzles are doing a superb job, as good as anything. And we are mitigating the risk of spray drift at that timing, because we know that the conditions that we have at pre-em timing make drift a much greater possibility than when we've got a crop to capture the spray.
I guess the other thing would be that obviously the last 2 autumns have been particularly challenging, but where we do have good autumn conditions or reasonable forecast, then actually timing drilling around when we know we're going to have a good spray window within 48 hours would be the way to make sure we can mitigate against those conditions again, isn't it? It's it's all
absolutely.
in the planning if there's time to do that, but
it's in the planning, and it's having enough sort of physical capacity, if you like. So, you know, having, you know, more spray capacity than you need is always a good thing. Like having more drilling capacity or combining capacity, it's always better to have more of it than be right on the sort of buffer, if you like. So yeah, if you've got more capacity, or you can build that capacity in by putting a spray bowser on to minimize the time that you're having to run back to the farm to fill up, so you really maximize the hours in the day that you've got. If you've only got a 6-hour spraying day, well, absolutely make sure that you get 6 hours of spraying out of that, rather than spending 2 of them running back on the road to the farm or whatever, you know. So look at the bigger picture and how you can really make it work for you.
So suppose you know of any handy tools that might help me to plan which hours of the day might be good for spraying in my local area?
It sounds like you're very much leading me in to say Spray Assist, Georgie, is an extremely useful app designed by Syngenta that provides the spray operator with, you know, a wealth of information, really to allow him to plan his day. Give lots of good advice on nozzle choice, and not just saying what are the best nozzles for you for that particular job, but actually looking at what are the nozzles you actually have available to you on your sprayer, and making the selection from those nozzles that you have available. It's not forcing you to go out and purchase new nozzles, but it's giving you advice based on the information that you're putting into that you have available to you. So yeah, Spray Assist is working extremely well, and the operators that we've got running that app do seem to like it and value the benefits that it's bringing.
Great stuff. Okay. Have you got any other questions, Matt?
No, I think that's pretty comprehensive. That it's a good bit of advice there, Scott.
Cool.
Okay, well,
that's great.
Thank you both for joining us. We'll see you soon.
Excellent. Thanks very much, Georgie. Take care.
Thanks, Scott.